The first part of the assembly video describes the main printing of the parts, how to assemble some of the subcomponents, the back frame, the front frame, the winding drum, the ratchet, the minute hand assembly, and the weight shell. The first step is to assemble the back frame. It is large enough that it needs to be printed as multiple components and then assembled using brackets, and there are a few spacers holding everything together. Start by adding some long pins to hold the two frame pieces together. The design has been modified slightly. It's evolved a little bit. The latest design has smooth rod instead of threaded rod, but the assembly process is the same. The pins will ultimately hold everything in alignment, and there are two different sizes of brackets, mostly because of the way for clearances. The smaller one goes on the front, and the pins stick out a little bit on the back side, and then the larger one goes on the back. And I like to put the screws in one from each side so that it can snug up, and then put one in from the other side. And that keeps the brackets nice and tight. And then the standoffs that hold the clock away from the wall also are aligned with multiple pins, and then screws hold everything in place. They're supposed to be a little bit tight, and there are 4 screw holes that will ultimately hold everything together. 2 that go really deep, those go into the center holes, and then 2 of them that will eventually hold the keyhole hanger, and they will only go through part way. That's why it was done in 2 stages, in order to hold it. One holds the bracket to the back of the clock, one set, and then the other set holds the keyhole hanger into the bracket. One thing that often helps is to just use a clamp and let that pull the parts together. I went off camera and got a stronger clamp and clamped them together. The next step is the keyhole hanger, and the hanger is sized, one side is beveled for the screw heads to fit into, and obviously the narrow part needs to go towards the top of the clock. That's where the clock hangs. And these go together a little bit easier. Now the clock needs a couple of standoffs to hold the rest of the clock away from the wall. There's a narrow standoff and 2 larger standoffs. The narrow standoff goes near the top, and the two larger standoffs go near the bottom, kind of near the center of the dial. The front frame is again a two-piece component held together with some pins and brackets and a few screws. The second part of the front frame is the bearing holder that goes near the bottom end of the clock. That uses a skateboard bearing that drops into the bearing holder and a small spacer. Make sure that the side with the clearance groove is close to the bearing. That just keeps the bearing from rubbing. 3 pins and a screw. That's it for the front frame. We can also put together the crank arm. That's just a simple part with one screw, or that's the winding key. And tighten it up. If it's too tight, it won't pivot, so loosen the screw up just a little bit. You want it to be able to rotate when you wind the clock. The two halves of the clock, of the frame, should now be able to fit together, and the winding key is going to sit on the top of the clock like that. Now we can assemble the winding drum. That's a prefabricated brass rod. There's a slot at one end and then a hole drilled 1/2 inch from the other end that will hold a small pin. The slot needs to be filed by whatever means, hacksaw, Dremel tool, such that the winding key will be able to slide on, and then that will be able to rotate. This brass shaft and the short 1 inch long pin fits inside the winding drum, and then it should push in. It may need a little bit of pressure. You'll never have to take it apart, so it's okay if it's a little bit tight. Then we need to add cord. I use fishing line. There is 2 holes, or a hole through the winding drum. Slide the fishing line through, guide it through the holes. And then just tie a couple of knots. I like to grab the end and hold it with a pair of pliers so I can really tighten the knot. And trim it so that the end is fairly short. And then measure out about 10 or 12 feet of cord. We can trim the final length later. That is going to eventually get wrapped around the winding drum. Let's see which way it's going to go. It will wind around this way. So I'm going to wind most of it around the drum, just to keep it out of the way. Next, we will assemble the ratchet, and that consists of the main ratchet itself, the upper hub that holds the clicks, 3 clicks, and a few other miscellaneous components. Each of the clicks there goes onto, what do I call that one? I think I call that one gear 7B. There is a beveled end for the screw to fit into. That's the direction that the screws need to go. Tighten them down, but then loosen the screw until each click is easily, loosened up, so there's no resistance in the click. And repeat this for each of the 3 clicks. Make sure that when it's loosened, that the click swings freely. Okay, that should be good. There are 3 pins from a ballpoint pen, or three springs. There's a hole in the hub and a hole in each click, and that will push the clicks away from the hub. Just go ahead and put the 3 pen springs into position. The main hub, I call this one gear 7B, goes onto the 3-inch large diameter arbor. There's a hub on the back that helps with the alignment. It helps keep this hub from wobbling when the clock is running. And the back should stick out, 2/10 to 1/4 of an inch. Then the assembly with the clicks goes into position, and you should be able to rotate it in one direction, and the clicks should push into the ratchet. That will be what allows you to wind the clock. Ultimately, there will be another spacer on the back side. The minute hand arbor consists of a couple of printed parts, the 4 1/4 inch long minute hand arbor itself with a slot cut in one end that slot needs to be sized so that the minute hand can actually fit on the end and hold securely. The assembly starts with a shaft coupler, and it needs to be positioned 2¼ inches from the bottom end of the minute hand arbor. And tighten the set screw on the shaft coupler and insert the small gear with a cutout for the set screw to fit inside. That should lock into position so that the shaft coupler is embedded in the 18-tooth gear. Follow that with the cover, pen spring, and the large 54-tooth gear. That should slip over the pen spring. And there is a key in the cover and in the large gear that needs to line up. That leaves just enough space on the back for the second shaft coupler. And when the set screw is tightened down, there should be a small gap between the two components of maybe a 1/16 of an inch, a millimeter, 1.5 millimeters. The arbor should stick out the bottom, about 1/4 of an inch, maybe slightly less. When this is all put together, what this arbor allows is the spring creates a friction clutch that allows changing the time without having to stop the clock. When the minute hand is on the arbor, that allows you to change the time without affecting the gear that power is transmitted to the pendulum. Although when the clock is running normally, the large gear rotates the minute hand. It allows you to change the time when you want to, but it holds it snug enough to hold the minute hand in place when it needs to operate normally. The next step is gluing up the pendulum shaft. Threaded rod would work, but I like to just use a 3-inch long bolt, 75 millimeters, and then grind down the head so that it just fits inside the arrow shaft, cut to the proper length. One end gets glued onto the upper support, the other end gets glued on to the bottom end, and there needs to be a pin through the upper pendulum support, and these two ends need to sit flat on the table when the glue is drying. If they're not flat, the pendulum bob will be at an angle, and you don't want that. Well, now when that glue dries, then you want to glue in the threaded rod. The purpose of the threaded rod will be to hold the finial, and that's how you will change the length of the pendulum to set the rate of the clock. And while the glue is drying on this one, make sure to support it so that it doesn't drop down at an angle. It needs to stay parallel with or in line with the main pendulum shaft. The next step is the pendulum bob, which is a 2-piece components filled with pennies, washers, small coins, anything. Pennies seem to be the cheapest, lightweight. So I just use those, but the weight of the bob is not that critical. you can basically fill the bob with anything you like, and it should run just fine. If you're using US pennies, it takes 42 pennies. Other coins or washers, it may be a different amount. But they should be all filled up. Insert the pendulum shaft so that the threaded rod sticks out the bottom, and then 10 small screws to hold everything together. And when it's done, the finial should be able to thread onto the bottom of that. There's a fair amount of travel that allows you to change the rate of the clock to set the proper runtime.